Hello students, welcome back. I am Rinkesh sir and today we are going to continue with the miscellaneous exercise 5 of chapter number 5, that is complex numbers and quadratic equation. Okay, so let's begin. Question number 1. Evaluate I raised to 18 plus 1 by I whole raised to 25 whole cube. Okay, so let's write down the first one. I raised to 18 plus 1 by I whole raised to 25 whole cube. Okay, so now say I raised to 18, I will express in the form of multiple of 4 plus. So 4 4 are 16, so it will be I raised to 16 plus 2 plus 1 raised to 25, that is 1 upon I raised to 25 cube. Now we know that we are taking I equal to I square minus 1, I cube minus I, and I raised to 4 equal to 1. Then we are repeating I raised to 5, 6, 7, 8. So I raised to 16, that will be the multiple of 4, that is equal to 1 into I square. So this will be equal to I square plus 1 upon I raised to 25, that I can write it down here in rough. I raised to 25 equal to I raised to 24 plus 1. That means I raised to 24, that will be equal to I multiple of I raised to 4. So 1 into I raised to 1, that will be I square, we know that the value of I square is minus 1. And 1 by I, that is minus I. We will use this shortcut, whole cube. This will be equal to, I will take minus 1 common, 1 plus I whole cube. Minus 1 cube, it will be minus 1. Now here a plus b whole cube, a cube, that is 1 cube, plus b cube, that is I cube, plus 3a square b, 3 into 1 into I, plus 3ab square, that is 3 into 1 into I square. This will be equal to minus 1. 1 cube is 1. I cube, that is minus I. So minus I plus 3 into 1 into I, 3I. Now 3 into 1 into I square. What is I square? Minus 1. So it will be minus 3. This will be equal to minus 1 into 1 minus 3. So it's minus 2 minus I plus 3I. So that will be plus 2I. Multiplying minus 1, I will get 2 minus 2I. Okay, or else I can take 2 common, 1 minus I. Okay, so this was about question number 1. So just note it down. Now let's move to the second question. Question number 2. For any two complex numbers Z1 and Z2, prove that real image of Z1 and Z2 is equal to real image of Z1 into real image of Z2 minus imaginary part of Z1 minus into imaginary part of Z2. So let's take Z1 is equal to A plus BI, or let's say A1 plus B1I, and Z2 is equal to A2 plus B2I. What is the real image of Z1? Real part A1. And imaginary part of Z1, that is B1. Same way, real part of Z2, that is equal to A2, and imaginary part of Z2, that is equal to B2. Now let's take LHS. What is LHS? Real image of Z1 into Z2. So real image of Z1 means A1 plus B1I into a2 plus b2i. This will be real image of a1 into a2, a1 a2 plus a1 b2i. Now b1i into a2, that is a2 b1i plus b1i into b2i, b1 b2i square. Okay, so this will be equal to real image of a1 a2 plus I can take I common from these two, so a1 b2 plus a2 b1 I, and I square, that is minus 1, so minus b1 b2. So I can rearrange it in form a1 a2 minus b1 b2 plus a1 b2 plus a2 b1 I. Okay, so now what is the real part? This is the real part, and I means this is imaginary part. Now we are asked real part. So this will be equal to a1 a2 minus b1 b2. So LHS is equal to a1 a2 minus b1 b2. Okay, now let's take RHS, that is real image of Z1 into real image of Z2 minus imaginary image of Z1 into imaginary image of Z2. So what is real image of Z1? A1. Real image of Z2? A2 minus imaginary image of Z1? B1. And imaginary image of Z2? B2. So again it's A1 A2 minus B1 B2. So from 1 and 2, LHS is equal to RHS. Hence, it is proved. Okay, so this was about question number 2. Just note it down. Now let's move to the next, that is third one. Question number 3. Reduce 1 upon 1 minus 4i minus 2 upon 1 plus I into 3 minus 4i upon 5 minus I into standard form means a plus bi. Okay, so let me write down first the question. 1 upon 1 minus 4i minus 2 upon 1 plus I into 3 minus 4i upon 5 plus I. So first, let's take LCM. It's 1 minus 4i, 1 plus I. Now 1 into 1 plus I, that is 1 plus I. Minus 2 into 1 minus 4i, that is 2 minus 8. I just cross multiplied it. Into 3 minus 4i upon 5 plus I. This will be equal to 1 plus I minus 2 minus minus plus 8i upon 1 minus 4i into 1 plus I means 1 into 1, 1 plus I minus 4i into 1 minus 4i minus 4i into I minus 4i square into 3 minus 4i upon 5 plus I. Solving it here, I will get 1 minus 2, that is minus 1, I plus 8i, that is plus 9i, upon 1. Now 4i square, that is minus. So it will be I square is minus 1, so it will be plus 4. So 1 plus 4, 5. I minus 4i minus 3i into 3 minus 4i upon 5 plus I. Okay, now let's multiply minus 1 plus 9i into 3 minus 4i. So minus 1 into 3 minus 3. Minus 1 into minus 4, that is plus 4i. 9i into 3, 27i. 9i into minus 4i minus 36i square upon 5 into 5, that is 25. 5 into I, plus 5i. Minus 3i into 5 minus 15i minus 3i into I 3i square. So now see 36i square. So I square is minus 1. So this will be plus 36. So minus 3 plus 36, that will be 33. And 4i plus 27i, that will be plus 31i upon. Now 25i, now 3i square. So I square is minus 1. So minus 3i square will be plus 3. So 25 plus 3, that is 28. And plus 5i minus 15i, that will be equal to minus 10i. Okay, now I can write down this as 33 plus 31i into 28 minus 10i inverse, right? So we'll use our shortcut, that is 33 plus 3i. Okay, 28 upon 28 square plus minus 10 square, so it will be plus 10 square. I will change this sign minus to plus. Numerator as it is upon 28 square plus 10 square I. Okay, now let's calculate it. First, let me write down 33 plus 3i into 28 upon 28 square plus 10 square. So 10 square is 100. So 28 square, 28 into 28, that is 784 plus 10 square, that is 100. It's 884 plus 10 upon 884 I. Clear? Now let's multiply 33 into 28 upon 884, that is 33 into 28, that is 924 upon 884 plus 33 into 10, that is 330 upon 884i plus 28 into 3, sorry, it's 31i, right? Here is 31i. So 31 into 10, 31 into 28, 31 into 28, that is equal to 868 plus 31 into 10, that is 310 upon 884 I into I square. Here 31 I into it will be I. So this is I square, so this is minus, so it will be minus 310 upon 884, right? So 924 minus 310, this will be equal to 614 upon 884 plus 330 upon 884 plus 868 upon 884, that will be equal to 1198 upon 884i. Now we can reduce it. Divide by 2, 2307 upon 442 plus 1198, that means 5 is a 10, 599 upon 442i. This is our standard form. Okay, so this was about question number 3. So just note it down. Now let's move to the next questions. Question number 4. Here it is given if x minus iy, that is equal to a minus ib upon c minus id. Then you have to prove that x square plus y square is equal to a square plus b square upon c square plus d square. Okay, so now see what here we can do. We can take the modulus. Okay, so taking modulus of x minus iy, that will be equal to modulus of a minus ib upon modulus of c minus id. Now, what is the formula for modulus? Under root of a square plus b square. So here we will get under root of x square plus y square. In this case a minus ib, so a square plus b square, and in denominator c square plus d square. Okay, so taking square on both the sides, I will get x square plus y square, and here square root will be removed. That will be a square plus b square upon c square plus d square. Okay, hence it is proved. This was about question number 4. Just note it down. Now let's move to the next question. That is question number 5. In question number 5, there are two sub questions. Okay, so first I will solve it, and second I am giving you to solve it by yourself. So let's see the first one. Here z is equal to 1 plus 7i upon 2 minus I whole square. And the question is convert the following in the polar form. So what is polar form? Polar form is equal to r cos theta plus I sin theta. We need to find out the modulus, that is r and theta. So first we need to rearrange in a plus ib form. So 1 plus 7i upon a minus b whole square, a square, that is 2 square 4, minus 2ab, 2 into minus I, sorry, into I, that will be 4i, plus b square, that is I square. Now I square means minus 1. So this will be 1 plus 7i upon 4 minus 1, that will be equal to 3 minus 4i. Okay, so this I can rearrange it in the form of 1 plus 7i into 3 minus 4i inverse, multiplicative inverse of it. So this will be 1 plus 7i. We'll be using shortcut 3 upon 3 square plus 4 square, right? 3 square, that is 9, plus 4 square, that is 16, that is 25. So 3 upon 25, I will change the negative sign to positive, upon 4 upon 25 into I. Clear? Now let's multiply it. 1 into 3 by 25, it's 3 by 25. 1 into 4 by 25, I, 4 by 25, I. 7i into 3i by 25, 21 by 25, I. Plus 7 into 4, that is 28 upon 25, I square. So I square is minus 1, so this will be minus 28 by 25. So 3 by 25 minus 28 by 25, that will be minus 25 upon 25, plus 4 by 25 plus 21 by 25, that is 25 by 25 I. Okay, so z is equal to minus 25 by 25, that is minus 1, plus 25 by 25 plus 1i. So here x equal to minus 1, y equal to 1. So modulus r under root of minus 1 square, that is 1, and y 1 square, that is 1, that is root 2. Clear? Now tan theta, that is equal to y by x. What is y? 1 x minus 1. So this is equal to minus 1. So when does the value of theta is minus plus 1? Tan theta is 1 at pi by 4. So here alpha will be equal to 1. Sorry, pi by 4. Okay, now we know that for first quadrant we are taking alpha. For second, pi minus alpha. For third, alpha minus pi. And for fourth, minus alpha. Okay, so here see, x is negative, y is positive. X negative on this side, y positive on this side. So this is in second quadrant. Second quadrant it's pi minus alpha. So theta is equal to pi minus pi by 4. This will be equal to 3 pi by 4. Okay. So our polar form, that is r. What is r? Root 2. Cos theta, that is cos 3 pi by 4, plus I sin theta, I sin 3 pi by 4. Clear? So this is the polar form of the first part of question number 5. Note it down. Okay. Now the second one is just similar to the first one, so solve it by yourself. Yeah. Let's move to the next questions. Solve each of the question in exercise 6 to 9. So 6 to 9, all the questions are similar. So I will just solve one for you and the rest you have to solve it by yourself. So I am solving the sixth question, that is 3x square minus 4x plus 20 by 3 equal to 0. So let's take the LCM, that will be 9x square minus 12x plus 20 by 3 equal to 0. So that implies 9x square minus 12x plus 20. When 3 is multiplied here by 0, this will be equal to 0. So A 9, B minus 12 and C equal to 20. So what is our discriminant? B square minus 4AC. So B square, that is minus 12 square 144 minus 4 into A 9 into C, that is 20. So 144 minus 9 into 4 36 into 20, that is 720. So 144 minus 720, this will be equal to minus 576. So root t, this will be equal to square root of minus 576. So square root of 576 into minus 1. So 57, sorry, it's 576. So 576, that will be equal to, I can write it down as 9 into 64, okay, into minus 1. So square root of 9, 3. Square root of 64, that will be equal to 8. And square root of minus I, that is minus 1. Okay, clear? So this, sorry, that will be equal to I. So now, what is our value of x? Minus b plus minus root d upon 2a. So minus b, that will be equal to minus minus plus 12 plus minus 3 into 8, that is 24. We can also write down directly here that 576. 576, that is the square of 24. So 24i upon 2 into a, that is 9 to the 18. So I can take 3 common, 4 plus minus 8i upon 3 into 6. So 3 3 gets cancel. Clear? Again I can take 2 common, so it will be 2 into 2 plus minus, or else I can directly take here common. 6. So 6 into, that means 2 plus minus 4i upon 18. So 6 ones are 6 threes are. So this will be equal to 2 by 3 plus minus 4i. So x is either equal to 2 by 3, sorry 4 by 3 plus 4 by 3i, or 2 by 3 minus 4 by 3i. Clear? So this was about the sixth question. Note it down. Okay, so that was about sixth. Question 7, 8, and 9. You have to solve it by yourself. It's just similar to question number 6. Clear? Okay, students. So that's it for today. In our next video lecture, we'll continue from question number 10. Thank you.